So welcome everyone. So I'm calling this ChatGPT Explained because we're not just demoing, we're not just doing prompt engineering, we're also explaining some concepts behind ChatGPT. So this could be a good refresher for you. Maybe you've seen some of these concepts before. Maybe you have some exposure to natural language processing. Maybe you have some exposure to machine learning. Maybe you're new to all of this, which is also fine because we'll be doing the demos and you can start catching up on some of the material. But like Nathan mentioned, we thought it would be best to break it down into two parts. So the first part is basics, getting introduced, doing a little bit of demos, playing around with ChatGPT, seeing what results come, making sense of it, understanding a little bit about the design behind ChatGPT and why it works, and then looking at a few more applications of ChatGPT. So that'll be part one. Part two will be where you start seeing things like chaining, LLM models, LangChain, looking at more natural language processing applications, looking at how ChatGPT could be incorporated in the industry by different companies. How do they think about fitting it in? Everyone's into generative AI, as you guys know. So it's a very hot topic and it has a lot of applications, especially where language is involved. Not just language, I mean, with GPT-4 and other models coming out, you can also look at language and vision. And there's also a separate set of large models for vision, which we'll not talk about in this part one. But part one and part two, that's how we're breaking it down. And so concepts, examples, a little bit of prompt engineering, and a little bit more. And then we'll move on to part two in a few months. So let me just get started. I'm Karthik Mohan. I did a PhD in ECE at University of Washington, Seattle. Then I worked at Amazon. Then I worked at Meta. Then I took up affiliation with University of Washington as a professor, where I'm still affiliated. And I do some part-time courses. I teach there at the professional master's program. And more recently, I joined Chewy.com, which is like, you can think of it as Amazon for pets and pet products as a staff ML scientist, which is where I'm currently positioned at. So today's talk, part one, we'll be going through some introduction motivation. We'll look at the engine behind ChatGPT. We'll look at some ChatGPT use cases for natural language processing. And we'll look at a demo, a notebook demo as well, which goes a little bit more into how do you think we can use ChatGPT? What are some machine learning and natural language processing applications that we can look into? So we'll kind of take a peek in part three and part four of this talk, but we'll also go more into it in the next talk. And the next part, we'll look a little bit more into LLM agents, also natural language processing applications. We'll look into LangChain, where you can chain LLM models. How do you fine-tune ChatGPT for application, especially in the context of industry? Every company is looking to see how they can incorporate ChatGPT in some way, or generative AI in some way. Like think about customer service. Think about when you want to interact with customers. Think about wherever you think a chatbot can fit in, and take off the load of customer service or having humans in the loop, making it easier for companies, making it easy for everyone. So there's a lot of fits. And also think of search, like you want to search on any, like on Amazon or wherever, and you want to have a bot work with you to retrieve results for you. Like if you go to Expedia and you want to make a change to your reservation, you're interacting with the bot, right? And then maybe a human actually shows up. But expanding that is what a lot of companies are looking at. How do you incorporate a ChatGPT generative AI style thing to outsource a lot of the communication that usually happens with customers in any of these contexts, right? So we'll look into more of that in part two. And then LLM as a service, like this also includes economics of using large language models as a service and issues that come up with it versus building your own model. So we'll look into more of this in part two as it gets more into depth. But first we need to cover the basics. So that's part one. So just setting expectations for everyone that we'll be looking at basics in this. But I hope it'll be interesting, even if you've looked at it before. And after every section, we'll pause for questions. So if you have any questions, we'll take a break after every section and we can talk about it. Okay, so let's jump in. So introduction motivation, right? So ChatGPT and LLMs are everywhere. It's become like water right now. Like you hear it everywhere. Everyone's having a conversation about ChatGPT or large language models, right? So this is like an infographic I pulled up from the web, where it shows what's the duration of time it takes to hit 100 million subscribers for different companies. Like for example, at the bottom you see Uber took 5 years to get to 100 million subscribers. If you look at TikTok, which is like more viral, video page, it took 9 months. ChatGPT only took 2 months, only to be beaten by Threads of Meta that took 5 days. But 2 months to just get to 100 million users is phenomenal, right? And that shows the popularity of ChatGPT and the likes, where people really want to use it, test it. They may not necessarily be having an industry application in mind, but people are really curious. They really want to know how it works, and you bring different levels of expertise as you use ChatGPT, and you have different applications. So 100 million users in just 2 months, that's the popularity of ChatGPT. This is another infographic I pulled from the web that shows the total number of visits in the last 1 month as of May 30th. So if you look at the month of May this year, and you look at the different offerings for large language models like Chat, GPT, Bing, you have Bard, and you have others. So if you look at the market share, ChatGPT really stands out with 1.6 billion people showing up in 28 days. Okay, so we'll switch a little bit. We'll look at some examples of working with ChatGPT. So if you have like a subscription, or you have an account with ChatGPT, you can also do this on your own. So I'm just going to stop sharing here, and then we'll go into looking at some examples. Okay. Oh yeah, so let me also mention that we'll look at some examples of paraphrasing. You want to paraphrase certain sentences, we'll look at some math, we'll look at some coding, all in ChatGPT context, right? So let's go check it out. So I hope everyone can see my screen. I have subscription to GPT 3.5 and GPT 4, so I'll just use GPT 4 here. Let's just get started with a couple of prompts here. Hey, hi, how are you? So it's just testing the waters. And then GPT says, hey, I'm just a computer program. I don't have feelings and emotions, but I'm here to assist you. That's great. Now let's look at some paraphrasing. So I have some questions here. So let's say I want to explain machine learning, right? Can you explain machine learning to a 5-year-old? Could I zoom in a little bit? Okay, let's do that. Okay, is that better? Hopefully that's better. So let's see. Yeah, okay, great. So can you explain machine learning to a 5-year-old? Of course. Imagine you have a toy robot. At first, this robot doesn't know how to do anything, but every time you show it a toy and say its name, the robot remembers it. If you show the robot a ball, many times it says ball. Later, the robot sees a ball, it thinks, that's a ball. See, this example is so easy to describe to a 5-year-old. So ChatGPT is kind of doing a decent job with explaining it. And it says machine learning is like teaching the robot to recognize things or make decisions based on what it's learned before. So using an example as a starting point and then explaining, I mean, this is maybe if you were to attempt explaining machine learning to a 5-year-old, this is what you do. Now let's replace this with, can you explain machine learning? What do I have here? To a college student. Would a 5-year-old know what a robot is? Yeah, that's a good question. But assuming you would, then this is probably how you would do it. Okay, machine learning to a college student. So now with college students, maybe you are used to getting into a little bit more technical details. So you see it's broken it up into data algorithms, training model, test and validation. And then in the beginning, it says it's a subset of artificial intelligence where a computer system is trained rather than explicitly programmed to make decisions based on data. Here's a more detailed breakdown. Okay. So definitely more nuanced, more details, more structure. and actually it breaks it down into data, algorithms, training, model, testing, validation, application. So definitely a little bit more. But let's go one step further. Can you explain machine learning to a computer science professor? So a computer science professor already knows this, but let's see what ChatGPT would do in this case. Here's a deeper dive. So look at the emphasis. Now it's not just explaining things at a high level. It's saying, I want to give you the rundown. I want to go deeper. So I'm going to really go and dig into the thing. So it's actually breaking it down into supervised learning, unsupervised learning, reinforcement learning, etc. Model complexity and bias variance trade-off. So these are things really getting technical. Like, if you had to prep for an interview, machine learning interview, you would be looking at these things: regularization, optimization, deep learning. That's great. So I know this person's already well versed, so let's dive deeper. So that's what ChatGPT is doing. Given the context, it is able to give more or less information for the same question. Okay, so we'll stop this. Okay, it stopped. So that's like paraphrasing using context to be able to get different kinds of answers. And this is really useful. We'll see at the end of this talk that we'll have another demo where we actually use this style of role play to have ChatGPT give different kinds of responses based on the role that's being assumed. Okay, let's look at math. Okay, so ChatGPT is not built for math. I mean, people know that ChatGPT is not like logically, very good, but it is able to do certain amount of logic in a very limited way. But it starts to break down in a while. So we'll see. So let's look at multiplication. So can you multiply 43 and 79? And I have the right answer here, so we'll actually verify if it's right. You can also verify. So it actually breaks it down. So the right answer is 3397. It got it right. Okay, so let's add a layer here. Can you multiply? So we'll do 3-digit multiplication: 432 and 799. 344928. Is that the right answer? That's the wrong answer. So it didn't get it right. Sorry, that's incorrect. Can you do that again? So now it's actually going to start verifying. So ChatGPT has a verification module where if it gets challenged, it starts to verify. So you'll see it starts verifying now. The correct answer. All right. Okay. Let's do the multiplication again. I made an error in the previous response. The correct answer is 344928. Okay. So you can see that it gave the same answer, and it says that the correct answer is this. So it actually didn't. It just, it's sounding right, but it's not giving me the right answer. So the right answer is actually 345168, I believe. Right. So you can see ChatGPT is not built for math. So doing all of this is actually going overboard for ChatGPT. We don't expect to be doing math on ChatGPT. We have calculators, we have Python programs that will give you exact math. So this is just to kind of explore the capabilities and understand that ChatGPT has limitations. If you focus on language, it'll do a good job. If you start going somewhere else, might have issues. Now let's. That reason I failed my math subject. Okay. Let's switch gears to coding. Okay. So if you're interviewing for a machine learning job or even software engineering in general, so you're probably used to coding questions. Let's look at a very basic coding question. I'm going to ask ChatGPT to write a code for Fibonacci series, right? So write a code to count the number of Fibonacci numbers less than n. So it's going to actually define a function, put in n as a parameter, and then it's going to write code that's going to count the number of Fibonacci numbers less than n, and then you can actually execute the code and it should work mostly. But let's see what happens. So it's writing a Python code. There are plugins for math. Yeah, that's true. So I saw a comment on that. Yeah. Yeah, if you didn't use the plugins, we have issues. But I think with plugins and chain of thought, you're actually adding capabilities to ChatGPT. So that's a good comment there. But even a pure language model is doing fine on 2-digit multiplication. So that's also interesting. Okay, switching to coding, count the number of Fibonacci numbers less than n. So this is a logic. So you guys can verify if it's right or wrong. It looks right to me. I mean, there may be some edge cases, but let's start adding a little bit of complexity to this, right? So let's say write a code to count the number of Fibonacci numbers that are prime numbers and less than n. And check for primality. So it's going to have a helper function that's going to check if a number is prime or not. So it's going to have that prime number logic. So great, it broke it down into two parts. First, check for prime. And the second is use the prime helper function and actually count only if it is prime. So you'll see if is prime of the next number, then count plus equals 1. So at least the high level logic looks good. And the helper function seems to be, I mean, I'm not going to check if this is prime or not. You guys can see if it's making sense and it's actually right for prime numbers, but at least at the high level, it's able to incorporate the helper function and then check if it is doing the right job. I'm going to tweak this a little bit. Okay, assuming this code is right, let's do something and let's see what happens now. So write a code to count the number of Fibonacci numbers that are, okay, let's see, negative. So negative Fibonacci numbers. So Fibonacci numbers are not negative. So the answer in the traditional sense should be 0. So you should get 0. But let's see what ChatGPT does when it encounters this variation. The number of negative Fibonacci numbers that are less than n. Okay. So it's actually able to understand that Fibonacci numbers are non-negative, and it's assuming that maybe I'm referring to the negative variation, so where you can go back and forth. So it's actually going to write a code and switch to that. All right, is this the right code? So every time I ask this, I get a different code. A couple of times I checked on this, I got the wrong answer. So one of the times the number of negative Fibonacci numbers less than n in the extended Fibonacci series is actually infinite, because you can keep going, like let's say n equals 10, and the extended Fibonacci series you have infinite number of negative numbers, but it was giving the wrong answer. So let's see here if it got it right or wrong. Check for the first number, change the negative Fibonacci numbers using the formula. Oh, yeah. Do you guys think this code is good? Any thoughts on this? So if you look at this, it says it has a while true statement here. So that means unless the while breaks, it will keep going forever. I mean, there is a break function here, but I don't know if that's the right one. But if you look at the extended Fibonacci series, there's infinite number of negative numbers in there. So the answer should be technically negative infinity, which you cannot count through a while loop. So you don't want to write a code for this if your answer is going to be infinity, because you will never actually finish if you wrote the right code. So this is an example where this is called behavior cloning, where ChatGPT is cloning a behavior it has seen before, for example, with prime Fibonacci or just regular Fibonacci, and extrapolating it to negatives. It got the part right where it said, let's look at the extended Fibonacci sequence, but then it's put in a while loop that can actually go for infinity. So we don't want that. We want to say that the answer is infinity and then stop. We don't want to write code that actually goes through a while loop. So these are some limitations where behavior cloning can go so far, but you might still get stuck with some basic logic. And that could be a limitation here. It's using Python by default. So I didn't specify Python here. But this is something I would play with and see what comes up for you guys. Okay, so those are three things I wanted to discuss: paraphrasing, math, and coding. So as you can see, as you get more and more nuanced with the logic, ChatGPT will start to fail. But coding is still good because there is structure, there's language. So ChatGPT can work with language, and that's why we see it is able to capture structure very well. But still, once it gets to like, you have a one-line answer, that's where it can start to falter. Right. It can handle improper English. Yep. It's no problem. Because it's based on tokens. So it doesn't matter how you add, you add filler words or not, articles or not, it's able to capture it. It's fine. Okay, so let's go over to the next. So let me go back to the slides. So that's the end of the first demo. And then we'll look at some concepts in the next segment and understand ChatGPT better, look at the history of ChatGPT. So I just thought we'll start with some demo, but go a little bit more. And I can also answer questions before the next segment starts. Okay, so we went through a live checkout of ChatGPT. So that was interesting. Every time I run the same code, I get a different answer. So that's another thing. There's randomness in the ChatGPT as well. Okay, so we are going into the next segment. So I can pause here for additional questions.
So Karthik, one of the questions is, does ChatGPT, does it use, like when you're asking it to code for you, does it use Python by default, or does it work based on your platform's environment?
So I didn't specify anything on the language, so I am assuming it works by default. Yeah, but you can probably ask it to change the language, and it would. So.
And then Josh is asking for your opinion. Do you find is ChatGPT getting worse over time or better?
So it depends on how the company behind ChatGPT is maintaining the model. So I believe, we'll talk about this, but they do reinforcement learning with human feedback. If they start identifying issues and keep adding data for it to fix it and fine tune the model, it will get better over time. So, but at the same time, you will not be able to capture all the errors that it makes and fix it. So if people are identifying a lot of errors and throwing it out, then it'll be hard to catch up. But the good thing is you can just say, hey, math, I want to add this chain of thought plugin. So don't rely on ChatGPT. Use chain of thought and use a calculator add-on so that you can do calculation with a separate engine. Things like that can take care of some big chunks of errors. So yeah, but I do believe they do continual training, which will hopefully resolve. It should have resolved a lot of issues by now, but there'll be always some incremental things that keep coming up that can be fixed. So I don't think it'll get worse over time, but it might just stabilize in terms of benchmarks. So when you compare ChatGPT against Llama or some other LLM models, it might just flatten out on some of the benchmarks.
Mm-hmm. And then last question before we move on, is ChatGPT using code snippets it's memorized, or is it writing this code word for word just, out of the blue?
So there is definitely memorization. But it's not like it just knows, okay, you asked me Fibonacci, so I'm going to generate this. So it's not like that, but it is doing a lot of pattern matching and understanding. It's like it uses the context that, okay, now I'm looking at code. So it switches to a code mode and then it will start generating things in that mode. So there's a lot of context that gets incorporated as like a precursor to generation. But the generation is, every time you ask ChatGPT the same question, you might get a little bit variation on the generation. So that tells you it's not like a pure copy paste from some memory bank that it has, but it does have abstract memory. So it has abstract memory and then on the run generation, just like we do. We have some abstract memory, but when you talk to someone, every time you talk, you might say a different sentence for the same question.
All right, so let's go on to the next part. And then I know, Bradley, I know you came in here with a question at the last minute, but I'll save it for the next section.
All right. So let's go to the next segment. So this segment, guys, is not going to have a demo, but it's going to go into some of the engine and workings behind ChatGPT, because you get demos everywhere, but going a little bit deeper into understanding of ChatGPT, I think that's important too. So I decided to spend some time in understanding the engine and the design behind ChatGPT, and like trying to understand why these limitations exist, and how to work with it. So we'll just go a little bit into that, and a little bit of history as well. So let's start. Sorry, I'm seeing something here. Okay, great. So engine behind ChatGPT, right? ChatGPT heavily relies on large language models to power its responses to users. So we'll go a little bit into language models and large language models. Again, this might be a refresher for those who are not new to natural language processing. You understand language models, you've seen some of this, but we'll not be spending a whole lot of time. But at the same time, if you're new to language models, this is a good place to get that knowledge in. So what is a language model? Language model is a scientific data-driven model that helps machines understand language and patterns in sentence construction. Like, how do humans construct sentences? We have a way of generating sentences, right? And we obey grammar, we obey certain ways of putting nouns and verbs together, and then we generate sentences. So ChatGPT or a language model would like to do the same. So that's the idea of a language model. A very simple task for a language model is, given an incomplete sentence, fill in the missing word. The missing word can be at the end of a sentence, or it could be in the middle of a sentence. So that's called a masked language model, where you mask certain tokens or words in a sentence and say, hey, I masked some tokens based on your understanding, based on your experience. Can you fill out the missing tokens and make sure the sentence is good, right? So it's like fill in the blank, fill in the missing word kind of a task. And that's a training data, right? So you train the language model to fill in the missing words, and that helps the model develop an understanding of language like we humans do, at least to some extent, right? So for example, I just got promoted, I'm feeling so frustrated. No, that doesn't make sense. You wouldn't say frustrated after promoted, you'd probably say happy, right? So I'm feeling so frustrated is valid. By itself, it's valid. But because you got promoted, you wouldn't say I'm frustrated. So using the context to fill in the missing word is important. I just checked my application status and it got dash. It's frustrating. What would you say? Well, rejected, maybe, right? That's the most likely word here, because frustrating is the next, it's in the next sentence. So something not so good happened in the first part. So you'd say rejected. Okay. So that's a language model, right? Having an understanding of language, predict the next word, predict missing words. These are the tasks that language models are trained on. I think in natural language processing, it started with hidden Markov models, very basic models. And then it went on to deep learning, and then from deep learning into transformers, and from transformers into ChatGPT, right? So we'll go a little bit into the breakdown of that as well in the next 5 minutes. So LLMs are large language models. So LLM is short for large language model. Are language models that are learned from massive, really huge corpuses of text. You can say from the entire web, and we'll see the scale of this. Like, this is really massive, like unimaginable scale of no human can go through this much text in one lifetime, or maybe even 100 lifetimes. That's the amount of text that these models actually look at. So large language models. So they look at a lot of data to understand language. And they are known to be very sophisticated, and they can also be generative in nature. So that is not just filling missing words, but actually generating entire sentences, generating an entire document like ChatGPT does, right? Just keep generating, and then you see it forms a beautiful sentence after the next. It makes a lot of sense. It's like someone who's professional is writing it. So that's the generative aspect. So let's look at a history of language models and large language models. So how did machines work with language before? And how do we do it now? This is an evolution over the past 20 years, maybe even 30 years. Actually, 1990s is when some of the earlier models started coming in. The 2000 and 2010 deep learning started making entry into natural language processing. And in 2015, 2017 is when the transformer paper came out. And then now it's all transformers in natural language processing. Okay, so we start with perceptron. Perceptron is like mimicking a single neuron in our brain or in our body. And a single neuron takes an input, and then the inputs can be from multiple axons, and then it generates an output. So you mimic it using a perceptron, which is basically taking an input. So you can see in the bottom figure here, it takes an inputs and sums it up, applies a nonlinear activation function, and then that's the output. So this is the mathematical description of a neuron. Of course, neuron has chemicals and electrical signals. We abstract that out to math, right? So that's the translation. So perceptron is like the fundamental thing that people work with. Logistic regression is one extension of perceptron that, as an algorithm, has been used, and it's also used these days as a baseline. Then you go to feed-forward neural network and say, chain a bunch of perceptrons. So not just use one perceptron or one neuron, have a bunch of neurons, and then maybe you do better. And then you also have these hidden layers here in green, which can help have deeper understanding of language, for example. And then people found that's not good enough because we want to generate one token after the other. And that's where recurrent neural networks came in. So chain neural networks in a recurrence fashion. So one after the other. And then you take in the first character, generate the next character. For example, here, you want to, after J, you want to generate A. After A, you want to generate Z. After Z, you want to generate Z. So jazz is what you get. So this is character level generation. So recurrent neural networks were a way to extend that. So you see, it started out really simple. It's like, okay, so just chaining it, it's no big deal. But then slowly and surely it gets complicated, right? The issue with RNN, recurrent neural networks, is it doesn't preserve long-term context. For example, if you have a sentence like this, I just arrived in New York. In a few days, I would like to visit the city. A recurrent neural network might just say New York because it's the most popular city. It just discarded the fact that I'm already in New York and says I would like to visit New York, right? So not having the context from the previous sentence, but still generating a sentence that makes sense. Like the second sentence makes sense. It's just not using the previous context. So as a whole, it doesn't make sense, right? That's what LSTM, long short-term memory neural networks, resolved. So they have longer short-term memory. So they can actually use context from before to actually make a better guess on the next word. So going back to the same example, I just arrived in New York. In a few days, I would like to visit the city, Seattle. Okay, that makes a lot of sense because that's not New York. So at least you got the bottom line right. So that's what LSTM is better than RNN, has a better memory. And then people also added attention, to start focusing on different parts of the sentence, like your machine translation. You want to paraphrase. I want to go from English to French. Look at where you are in the English sentence so that you can translate the French sentence. So that's paying attention. So the concept of attention is also there in transformers, but it started with LSTMs, right? And then came transformer. Now transformer is like the building block for modern and popular language models, right? All LLMs, you look at Llama, Bard, ChatGPT, all of them have transformers sitting somewhere inside there, right? Some kind of a transformer sitting inside there. So transformer is more nuanced. It takes off from where LSTM left off. We'll not go into the details of transformers here, but it has a way of doing attention that's more sophisticated than LSTM. And it has, so we'll not go into this, but it has an encoder and decoder. And different types of transformers use either encoder or decoder. For example, if you want to do sentiment analysis, you can use BERT, which is encoded representation. It gives you a representation for a sentence or a review, and then it can predict a sentiment, right? Or you want to do summarization of data. Again, you can look at an article and say which parts of the article would be good summary. So that's like picking out specific sentences. BERT would do a good job. So this is not generative in nature. It's using the encoder part of transformer. There's a decoder part of transformer that does more of the generation, right? So there is, that's a difference between GPT and BERT. So BERT is purely encoding transformer, whereas GPT is purely decoding transformer. So it just focuses on generation. BERT focuses on discrimination and classification and encoding representations, right? So GPT was one of the decoder large language models, from where GPT-2, GPT-3, and GPT-4, and then now ChatGPT, all of that came from GPT, right? So it started with decoding transformers. So we have GPT-X, right, that are trained to predict the next token given the past, or missing tokens given the whole sentence. And they are very sophisticated, and that's why they can, and they use billions of data points, and maybe these days even trillions of tokens. And that's why they're able to do some abstract memorization, but also understand sentence construction and do a fantastic job in generating entire paragraphs that look logical, grammatical, and structured, right? So sentence construction is very, very nuanced. Okay, so actually, I might just pause here if we have questions, because this section is a little bit more involved. Or do you think we should go on, Nathan?
Nope, sorry. I was trying to find Bradley's question in the chat, but so Bradley wants to know, does ChatGPT take interactions from users into its model like a chatbot, or is it more restricted as to who trains it?
Interactions from users. You can pass in context in ChatGPT and provide a lot of context. You can pass in examples, so that's few shot learning, zero shot learning. So those are inputs from user on top of what was already trained to kind of fine tune it on the spot and generate better responses. So that's definitely part of prompt engineering, and passing good prompts and passing in good context. You can give a lot of context and say, okay, now I want you to answer this question. So in context, that's called in context learning. So you already have trained a model, but you pass in more context, and then ChatGPT would give a different response. So yeah, definitely you can pass in a lot of context and ask it to respond accordingly. So users can have a lot of say, and that is why prompt engineering has become popular, because users have a lot of say in how the responses come out and how they want it to come out, right? So that's the engineering part of prompt engineering. Yeah.
Cool. And I think RJ's question was just answered with that, which is, ChatGPT is a fixed static model and doesn't change due to user input, right? So I think with the context, it will change.
Yeah. With the context, it changes. Yeah. I mean, it's like a model that's already trained, but then with the context, it changes. So it's like a parameterized model, you can say. So you have the control over the context. Yeah.
So then Anita wants to kind of going in another direction. So if ChatGPT doesn't remember, my chat changed. So if ChatGPT doesn't remember what is being entered by users, why are businesses banning the use due to privacy concerns?
Well, there's no saying that what you enter will not be logged, right? So it just depends on the agreements that are present. So it's just a matter of, is it getting logged? Is it getting seen somewhere else? Will it go back to training data? Will it go back to the web? Anything on the web is up for grabs. So anything that you put out there. So we have to look into the fine print, but sometimes some things can get logged. Sometimes some things can get used as training data. So that's where companies are being very careful with what they expose to ChatGPT.
Okay, and then last question before we continue. What is the most active area for further research for innovation currently relating to transformers, encoders, decoders, etc.?
Yeah, I think the logic part, incorporating more logic and reasoning into ChatGPT is an active area of research. I mean, there is like things like chain of thought, adding extra modules for specific skill sets like math or coding, or specializing ChatGPT for different purposes. Like there is a Code Llama that recently came out that's focused on coding, so it'll do a good job on coding. So specializing ChatGPT like frameworks for specific tasks are something that people, academia, open source folks, and also industry folks are looking at Like there was one recent example where someone went to do shopping with with a shopping site, and they were ordering something and they were interacting with the chatbot, and they said, "Hey, can you tell me what 2 + 2 is?" And it said 4. Like that's an irrelevant question that you're asking on a shopping site, but it's still answered because it's being trained on top of some kind of a chat GPT. So, companies are looking to use specialize generative AI into specific domains like medical domain or whatever. So those are going to be the next frontiers, is to specialize and do really well in those areas, among other things.
Okay, perfect. And because of time, I think any other questions that get asked will just save for the very end.
Yeah.
So
Yeah.
if you're, and again, reminder, if you're in Zoom with me, I mean, I know you guys have been asking questions in the chat and I've been able to follow along, but if you can just ask them in the Q&A tab, just help me make sure I don't lose them. All right.
Okay. So let's look at ChatGPT framework. How does ChatGPT, how do you break down ChatGPT? Like this is for understanding, right? So one is pre-trained LLM. You saw GPT-X is a good starting point, but it's not enough to actually have a conversation like we see on ChatGPT. So what they do is they add on to pre-trained LLM, which is a very huge model. Like, you and me may not be able to train it because of trillions of tokens and billions of data points. So only a few companies actually work on pre-trained LLM training because it's very expensive as well and requires a lot of resources. So, but on top of that, you can add on supervised fine-tuning on high-quality data. So the first one is low-quality data mined from the web. Like if you use data from Reddit, you'll start seeing that the language of the GPT becomes very toxic. So you need to weed out some of the low-quality data. And so you add in fine-tuning with high-quality data that might be 100,000, 10,000 to 100,000 data points. And then on top of that, the innovation more recently has been to use reinforcement learning with human feedback. And this is more sophistication in guiding ChatGPT to better responses. So we'll look into this. So when you add these three things as a recipe, you get ChatGPT, or you get Llama or other variations that we see in the market. So they usually have these three, or Anthropic. Anthropic also has reinforcement learning with human feedback. So these three things coming together makes them more fine-tuned for a prompt response kind of input output. So pre-trained LLM is not for prompt and response. Supervised fine-tuning is trained on prompt and response. Reinforcement learning with human feedback is differentiating good responses from bad responses. So it's going one step further. So when you add these three together, that's how you get a more sophisticated, nuanced engine like ChatGPT. Okay, so this is something I pulled out from Chip Huyen. He's a famous she's a famous data scientist, and there's a very good blog that I would refer you to. You can take a look. So I pulled this up from there. So you can see that in terms of the stages, right? There's a first stage, which is pre-trained LLM. The first column, that's on 1 trillion tokens. So you can see like massive amounts of data is used to train this. And then there is supervised fine-tuning, which is on prompt response pairs. That's usually 10K to 100K. And then you have Instruct GPT or Chat GPT or other variations that are very fine-tuned for instructions. Like, here's an instruction, I will follow it very well. So, and there's human feedback that says, this response from Chat GPT is better than that response. So there's a reward model, there's reinforcement learning, you optimize the reward model so that you can do better. So there's all of that. So we'll not go into details here, but it's a very interesting thing. But at the high level, it's like the first level doesn't look at prompts, second level looks at prompt response, third level looks at comparison between responses. So in terms of training the data, this is a differentiation between the first, second, and third level. So the third level is very nuanced, and the second level is also needed. So people usually use 1, 2, and 3. Some people use 1 and 3 as well, directly 1 to 3. Some of the models use 1 to 3, but usually 1, 2, and 3 are used for something like ChatGPT. So that's why, in terms of a conversation, having ongoing conversations, these models do well because they're trained to generate good responses, and they also take into account context. So that's a bit on the design aspect of ChatGPT. In terms of tokens, like let's look at 1 trillion tokens, right? So Red Pajama is an open source version of Llama, which is a model released by Meta. And there's also Llama 2 that got released recently that is very comparable with ChatGPT on different benchmarks. Llama itself is a lightweight model as compared to ChatGPT, which is multi-billion or 100 billion parameters, but Llama only had like 10 billion. But Llama 2 has 70 billion, so it does much better. So there's two things, parameters and then tokens. Tokens is more on the data front. So Llama and Red Pajama deal with 1 trillion tokens. So let's understand 1 trillion tokens here. 1 trillion tokens require how many books? Can you guys guess? How many books would you need to read or parse through before you get to 1 trillion tokens? So one book is 50K tokens. Roughly, you'll see 50K tokens come out. 50 tokens are like subwords or other ways of tokenizing sentences, but you can say it's more fine-grained than words. So let's say how many words are present in a book, multiplied by a factor of 1.5 or something, and you get the number of tokens in a book. So a book typically has 50K tokens. To get to 1 trillion tokens, you're looking at 15 million books. So in terms of data, these large language models have mined through 15 million books equivalent of docs and on the World Wide Web to actually train their models, right? So it's a lot of information, a lot of data. Okay, so we'll switch into the next segment. Maybe I'll take questions after this because it's a short segment. So let's look at some ChatGPT use cases for NLP. This will go into our last. The last demo as well. So natural language processing can also benefit from ChatGPT. So ChatGPT is part of natural language processing, but there are natural language processing applications that can benefit from ChatGPT, and that was one of the topics. That was one of the topic of this talk. So I'll talk about it. If we look at the distribution of use cases that are used for Instruct GPT, you see that it's used a lot in open question answering, generation, brainstorming, rewriting or rephrasing, summarization, etc. Right. So brainstorming could be something like list 5 ideas for how to regain enthusiasm for my career. Rewrite is this is summary, rewrite in this way, or generation is write a short story. So just generate something, right? So these are typical use cases. So in this talk, we'll look at a couple of use cases in terms of the demo. One is prompt engineering for information retrieval. So we'll look at keyword extraction given a body of text. Second is data augmentation. This is a very important innovation that's coming out of ChatGPT. Is if you think that ChatGPT is doing a good job in answering questions, maybe it can also annotate data, and you can use it as ground truth or gold standard. So then you actually can use ChatGPT to annotate data and then train a smaller model in your company based off that, assuming that you've taken care of privacy issues of exposing your data to ChatGPT, right? So if that's taken care, you can do data augmentation using ChatGPT, and that leads to transfer learning to smaller models. So if I want to deploy a model in a company, latency is an issue. LLM as a service can be very expensive, or there's rate throttling issues. So you want to own the service. You don't want to take a dependency on LLMs outside if there's no reliability on cost or data extraction, then you want to do transfer learning. So these are like 3 things I want to touch upon, but mostly the first 2 for this talk because we don't have enough time. We'll probably go into the second one, the third one in the next talk. There are more use cases, like you can use OpenAI embeddings for semantic search, right? So they have really good embeddings that come out of these large language models that can be used for semantic search as well. So, but that's not a chat-based use case. The first 3 are based on ChatGPT. All right. So more on this will be coming up in part 2 of this talk. So that'll be in a couple of months. So maybe you can watch out for the next announcement for the part 2 of this talk, and we'll go more into depth on that. Okay. So considering the time that we have left, I will just go right into the notebook demo, which will be the last segment of this talk. But maybe we can take a couple of questions before that. Nathan, do we have time for questions?
Sure, let's take a couple. So Frank wants to know if we're on the right path, and I'll give you some context. So Frank's hoping that we're not putting too much hope into generative AI, and are we creating a bubble with all this hype, like to say that digital intelligence is only about customers in IT, And we're notorious for hypes and over promising but under delivering. So are we on the right path with generative AI, or is is something being overpromised?
So yeah, that's a very good question that Frank has asked. So I don't worry about overpromise because you if you overpromise and then something happens and people say, okay, you go back to the drawing board. But I'm more worried about its use or misuse, right? So that is something to manage, whether it's with language models or with images or videos. Um, we need like more ethics in AI that starts to come in as these models become more pervasive. We want to make sure data leakages or misinformation, misuse of data, misuse of generation. These things are more troubling, and definitely we cannot brush it under the carpet. So I think ethics in AI is going to be a big one, and we'll probably see a lot of attention going forward as these models start to get more and more incorporated. Data privacy issues, data morphing data, these things become an issue as well. So I think those are caveats. But that said, it's just like when computers came out first and people say, oh, people can hack into your computer, or there's viruses and that can crash your system, and then you say, okay, just install antivirus, and then there's like phishing and there's all kinds of hacks that people do, and just have to guard yourself against it. So but the use case for a computer is very big. Like you cannot do without laptops or computers these days. So the same way, the use cases for generative AI is huge. So we want to focus on the positive sides of it while guarding against the misuse and negative side. So that needs to be taken care as well. So it's just that we're getting used to it. It's not a hype, I feel, because, for example, the coding part, a lot of coding is repetitive in nature. It will save a lot of man hours if you use coding based on Llama or ChatGPT, right? Or specialized large language models for coding. You save a lot of man hours coding. So yeah, use it where it makes sense and it saves your time, definitely. Customer service, you can have safe large language models that are safe and not toxic, or are retrieving the right information and doing the right job. They can be very good for customer service. So there are very good use cases for all of this, but we just need to guard against any misuse. That's what I would say.
I'm muted. Let's move on to the next session here, and then we can answer any other questions at the very end.
All right. So we'll have the next segment, which is notebook demo. I'll just stop sharing here. Okay. All right. So here I have a notebook. I have it on Collab. You guys can also probably have seen something like this. You might, or you can just set it up. It's not too complicated. You just need a OpenAI. So I'm using OpenAI here. You just need an OpenAI key. If you're using Llama or something else, you want to get a API key for that, and then you can start working on it in a notebook, right? So this is already set up, OpenAI and some basic libraries. And then I've also mounted a drive where I have the notebook stored and the data stored. And then this is the OpenAI key. I've saved it in text, so I don't want to expose it to you guys. But I'm loading the key here, and the OpenAI key is already loaded. And then there is also, this is the one where given a prompt, you get a response. So this is like the function and API call that we make every time we want to get a response from ChatGPT. So here the model is GPT 3.5 Turbo. I'm not sure I can change it to GPT-4, but I haven't tried, but maybe I can because I have access. So I haven't tried that, but you can specify the model. There's other hyperparameters or config parameters you can specify here. And then it will generate a response, and that response is the answer to the prompt, right? So this is also loaded up. So the first thing I want to look at is a prompt for keyword extraction. So here's the input to this function is to get keywords from a text. So let's say there's a list of text, or let's just assume there's one body of text. Here's a prompt that I designed or used to generate 3 keywords for a body of text, right? And it's very descriptive. It's also precise. It's giving context. There's different themes to this prompt that makes it work. So it says here's a list of strings, which is maybe one string that's delimited by 3 quotes, which is what is the input here. And for each string in the list, generate at least 2 keywords and at most 3 keywords. So I'm actually giving it very specific instructions and then return result as the list. And the keyword should be relevant to the text, and each keyword can capture a different popular theme of interest. And the keyword doesn't have to be present in the text, and also keyword shouldn't have a space in it. So these are the, this is like being very detailed, right? So and then there's a text here that I borrowed from a book that I like. So I'm just using that. It's a little bit more on the wisdom side. So you see there's like things about understanding the human psychology. So this is about that. And then I run this and I get 3 keywords, boundary, defense, and knowledge. So this text is about having healthy boundaries and being defensive and about knowledge. So it identified 3 keywords and it generated that. So it's doing a reasonable job, right? And then there's a whole book that I actually loaded. So it's called the book Intimate Note of a Sincere Seeker by Sri Sri Ravi Shankar. So I use that as my database. Each page in that book is a data point, is a text, right? So I load that. Okay, so that's loaded. Now I can generate keywords for hundreds of those documents or hundreds of those pages at once, right? So let's try this. Oh, okay. So I need to actually just a second here while I see what I want to do here. Okay. All right. So let's generate all keywords. Let's generate all the keywords for all the pages. So it starts generating different. So let's look at this one. Key equals 29. Why do you respect someone? Because of their good qualities, right? Like honesty, word. So then it's able to generate the keywords: respect, self-respect, greatness. But if you go down, yeah. So here you see it's actually combining words and giving me words that have combinations, right? And maybe I only want one. It's giving me 2 words that are chained. So I just want to highlight this as a use case for prompt engineering, where I go back and I say, so I'm just going to copy this commented text and add it to the prompt. Okay. So make sure the keyword is just one word and not 2 words joined, like we saw, right? So that's how I do prompt engineering so that I get what I want. And then I go back and I do generation, and let's see what happens. All right. Okay. Yeah. So these were the last 2, I think, where the words were joined, and now you see they were not. So I'm getting keywords that are not a combination of 2 words. So the prompt that the sentence I added onto the prompt actually made a difference in the generation. So you see that the keywords are distinct rather than a combination of words. Okay. So that's the first application, just generation of keywords. The second one, which is actually very interesting for machine learning folks, is data augmentation. Data is always an issue, and we want to be able to generate data. So we can actually use ChatGPT as ground truth. So here I'm going to generate questions for the text to form a QA pairs, right? So I think of the text as an answer. I want to generate a question for the answer. The question doesn't exist, but we ask ChatGPT to generate the question. And that's how I'm generating the question answer pairs. And that's data augmentation, and I can use it for training a smaller model. And that's transfer learning, right? So that's application 2 that we'll look at here. So I define some functions, generate questions for a single text. And again, it looks very similar to the keyword, generate 2 distinct questions whose answer would be the text. One thing I actually mentioned here is very specific, is one question should be something a 5-year-old would ask. And the second question is something a mature adult would ask. So I'm actually specifying the exact type of questions I would want ChatGPT to generate for which the text is the response. Okay. And then let's just run through it. And let's see, we're looking at key equals 316. So we'll wait for 316 to come up. Okay, 316. All right. So here's a text. Why does someone lie to their close ones or to their beloved? This is a question often asked by lovers. Love cannot stand on truth, etc., etc. So this is about lies and in the context of love. So the 5-year-old question that ChatGPT generated was, why do people sometimes tell lies to the people they love? Very simple, direct, and of course, it's probably not a 5-year-old, maybe a 10-year-old would ask this. We can debate that. But an adult question looks more sophisticated. You see here, how can love and truth coexist in a relationship without causing harm or bitterness? Okay, so more sophisticated, but asking the same kind of question. So this is using the context to actually generate different questions. And that's something that you can add on to the prompt. So this is another application in natural language of data augmentation that you can use to train smaller models. Okay, right, I'll stop sharing. Let's go back to the slide deck. So we'll finish up and then we'll take last questions. So we looked at a demo on prompt engineering, keyword extraction, and data augmentation in Python notebook, where we actually call the API to extract responses. And some pointers for effective prompt engineering is clarity in instructions. So in the example from the notebook, we had this sentence that said the keyword doesn't have to be present in the text. Also, the keyword shouldn't have a space in it. So we're very clear in the instruction or the goal in the prompt, right? So clarity is important to get a good response from ChatGPT. Second, provide context. Example from the notebook, one question should be something a 5-year-old would ask. Another should be something a mature adult would ask. So this is giving context to shape the response you expect, and being specific and being concise. Generate 3 distinct keywords that capture the most important topics in the text. So being very precise and concise also helps generate good responses. So in summary of the talk, I think we're hitting the time, but we looked at introduction and some ChatGPT examples. We were just like looking at the interface, we were playing around with it. We looked at history of LLMs and ChatGPT engine, the makings of ChatGPT and how it performs well and why it performs well and how it's trained. We looked at some NLP applications of ChatGPT, specifically through a notebook demo. And then we also looked at some basic principles for prompt engineering that can give us effective responses from a model like ChatGPT. So next talk, which will be coming up in a couple of months, I don't know, Nathan will let us know, is we'll look at more on industry scale applications of ChatGPT. And this is something everyone in the industry is excited on, is to see, I want generative AI in my company. How do I make it happen, right? And there's a lot of questions there: privacy, scale, cost, using it as a service, building your own, fine-tuning, a bunch of choices. There's no one way to do it. So this is something that people are still figuring out recipes to do industry scale applications of something like ChatGPT. Then we'll also look at LangChain, which is chaining large language models. Demo on this in the next one. Fine-tuning ChatGPT for your application, again, tied to number 1. And then we'll look at a little bit on LLM as a service, where it's viable, where it's not, the economics of it, rate throttling issues, and other things that come up with using LLM as a service. That's about it. Thank you.
Awesome. Thank you, Karthik. So we're a bit over time, but we'll get some questions answered and then head out here. So one of the first questions was actually asking if you were going to go over fine tuning in the next session, and we answered that one. So the short answer is yes, we will go over fine tuning in the next one. Another question, and we haven't talked to you about this yet, so I don't want to promise anybody anything, but we have some people asking if the Colab notebook and if the slides will be available. Karthik, we can maybe shoot a couple emails back and forth after this. And if for everyone, if it is available, and again, I'm not promising anything, but if it is, we'll actually include it as a resource with the recording. So just look out for the recording, and you know, if it's there as a resource.
Yeah, I'll probably publish it to GitHub, and maybe we can point that as the link, Nathan.
Okay, sounds good. And then there's another question: can we teach ChatGPT to learn more than it currently does? And I think we sort of answered that when we were talking about using context in our questions.
Yeah. Yeah, there is like, yeah, in context learning, there is a lot you can do. But in terms of changing the model itself, that's up to the creators of ChatGPT or open source models. They get more data, the model improves over time. But there's like long-term improvement of models and there's like short-term quick improvements, but not very significant. That's in context. But there's long-term improvements that's not in our hands. But there's also fine-tuning that's like midterm improvements. That's something that we can do as well.
Mhm.
There's these three buckets, I would say, in terms of improvements.
Yep. And then our last, or maybe I should say, uh, where do recordings get published? I'm thinking this person, I think your name is Amity. If you go to Data Science Dojo's YouTube page, you'll see it there. And then if you go to datasciencedojo.com slash, I think it's just slash tutorials, you'll find it there as well. And then Karthik, I saw you just answered the last question there. So again, everyone, thank you so much for being here, and a big thank you for Karthik. We will have a part 2. We'll just have to look at our schedules to see when we can get up there. Usually